Let's begin. Today is May 30th, 2024, and we're doing the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 3, 9, 11, 16, 18, and 22, and uses the orange verification cards. The unique idea above is your way to search on turingmachine.info for this particular puzzle. Let's go solve. All right, so in our grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. And in the bottom row, we've got criteria card D, criteria card E, and then finally criteria card F. So criteria card A looks at the middle digit, the square digit, and compares that value to the number 3. Should the square digit be less than 3, equal to 3, or greater than 3? Criteria card B will look at the 3-digit code and let us know how many of those digits are 3s. Are there no 3s? Is there 1, 2, possibly all 3 of them? Criteria card C compares the first and the second digit, the triangle and the square, and lets us know whether the triangle should be less than the square, should they be equal, or should triangle be greater than the square. Criteria card D again looks at the 3-digit code and will let us know how many more of each kind are there. Are there more even than odds, or vice versa? Are there less even than odds? Criteria card E will take the sum of the 3 digits, triangle, square, and circle, add them together, and let us know whether that sum should be an even quantity or an odd quantity. And finally, criteria card F will let us know something about the order of the 3 digits. Are the 3 digits ascending, meaning they're slowly increasing, or vice versa? Are they descending, meaning they're getting lower, or there's no order to them? So the ascending example is 1, 3, 5, descending is 4, 2, 1, and the reason that 2, 3, 1 is considered to have no order is because it starts off at 2, it goes up to 3, but then descends or goes down to a 1. That's why it's considered to have no order. And remember, our objective today is to find this unique 3-digit code that abides by all these criteria cards. We're going to start off with our proposal of 314, and so let's go ahead and start testing. I want to find out how many evens to odds there are. So I'm going to test criteria card D. Okay, so the Turing Machine approves of my proposal. Remember, I started off with 314. There are indeed more odds than evens, or evens are less than odds. So that's what I'm going to put down for my notes in section D, that there are less even than odds. Okay, so what that means is there's 2 possibilities. It could be that there is a single even and 2 odds, or potentially all of them are odd. And I believe criteria card E will let us decide which one that is based on their sum. So I'm going to go ahead and test criteria card E. Okay, so the Turing Machine does not approve of the proposal 314 for this criteria card. Notice that if I do add up my 3 digits, 3 plus 1 is 4, 4 plus 4 is 8, that is an even quantity. So the Turing Machine does not approve of the sum being an even. So indeed, the sum has to be odd. So that's what I'm going to write down in my notes for section E, that the sum of triangle plus square plus circle should be an odd value, must equal odd. Okay, so why is this helpful? Well, the only way you could get a sum that is an odd of 3 values is that if 2 of them are not paired up but are of equal type, right? So 2 evens add up to be an even, but so do 2 odds. And so once you have that even, the only way you can get a total sum that's an odd is you have to have a lone odd value. So that means that if I put my clues together between D and E, that means that I have to have all of them be odd. So in addition to D, I'm going to say they are all odd. Okay, so again, the reason is I know I have more odds than evens, so at least two of them. But if I only have two odds, that sum is even, plus an even remains even. But I want it to end up being odd, so I need to have all of them be odd. Okay, so together those clues means that I can eliminate all the 2's and all the 4's. That's very interesting how this combination of cards will allow us to figure out that there are no evens at all. Very interesting. Okay, so I've tested D and E. So there is a little bit, we could figure out if there's any kind of order to it. There's also trying to figure out how many 3's there are. We could also compare the first and the second digits, as well as find out what the square digit is. So a lot of unique questions to query the Turing machine. And I believe I'm going to test, let's see, there's no mention of pairs or anything like that. I guess by definition, if there's no order, I guess you could have a pair of values. So let's see. And I do have 3, 1, 4, which is by definition no order because it goes from 3 to 1, it goes down, but then it goes back up to 4. So let's see. Would that be beneficial? Yeah, you know what? I think I am going to test criteria card F and see if there's any order. Okay, so it does approve of the proposal 314. So therefore, that means that there is no order to the 3 digits. Okay, so that does it for this round. I've already done my 3 Turing tests. So now I'm going to the phase where I have to sort of figure out what my second proposal is. So since there is no order, again, it could be as simple as say like maybe a 315, but we also have to consider that if there's a pair of numbers like next to each other, that would also constitute no order. We do have that equal for triangle and square, but let's see, there's also 3. So notice that we do have 2 criteria cards that are specific to square and triangle, but there isn't one specific necessarily for the circle. So I'm wondering if somehow circle may be forced into, one of these odd values. And the only thing that sort of comes to mind is that, let's see, or maybe triangle. Could triangle be 3? Almost like a 314, but maybe a 315? Because at least we know with square, we'll know there's no even, so we'll know, which odd it is based on, is it less than 3, equal to 3, or greater than 3? And let's see, if square were to be 1, and assuming they are all distinct, could it be 513 in case there is a single 3? How would you decide if square were 1, which one would be the 3? Because both 3 and 5 are greater than 1. How would you decide? So I'm almost thinking that it may not be 1 for square, because I don't see how to distinguish triangle from being 3 and 5. All right, so I think I'm gonna say square is gonna be 3. Then that would imply well, no. If it's 3, oh, they could be equal. They could be equal. But then how would you, yeah, so I don't think they're gonna be equal, because if they are equal, how would you decide? I guess you could say it's 1, 1, and there could be a single 3. So by default, circle would be it, would be that 3. If there's 1, 3, and we know square is less than, and they're equal. So it could be 1, 1, 3. What else could it be? Could be 5, 5 if they're equal. Okay, so yeah, let's go ahead and try 1, 1, 3. Let's go ahead and see where that leads us. Okay, so let me go ahead and test criteria card A. And so the Turing machine does not approve of my value being less than 3. Right, my square digit is 1, and that is definitely less than 3, so that is not correct. So either square is equal to 3, square is either equal to 3, or it's going to be greater than 3. Okay, so we definitely know it's not a 1. So let's go ahead and cross that out. Okay, and now let's go ahead and test criteria card C, comparing them. So let's see what that gets us. Okay, so that is also, it disapproves of. They're not equal. So that means that we know that triangle is either less than or greater than. And that's criteria card C. So triangle is either less than or greater than square. So definitely not equal. And so that just means that it can't be 3, 3 or 5, 5. And let's go ahead and test criteria card B for the number of 3 digits. Okay, so there is a single 3. Okay, so the Turing machine did approve that. So for B, I'm going to say there is a single 3. Okay, so let's see, what does that tell us? We may have to start listing out potential solutions and seeing if we can deduce the answer. We may have to go into a third round. So let's go ahead and test and see what we can get. So if triangle were to be a 3, so let me do it in the top row up here. If triangle happens to be 3, that would mean that, and we know they're not equal, that would mean that it definitely would be a 5. And I guess, could we say 3, 5? It would almost mean that this is irrelevant, because you already know what it's going to be. That triangle is less than. So I'm not sure if that's how that's intended to work, where it would lead you to that. And so, and also there's really nothing to say of what circle could be. How would you distinguish 3, 5 for triangle and square, and then circle could be any of these, 1, 3. Well, it definitely couldn't be a 3, because we know there aren't 2 3s. Likewise here, it can't be 3, 3. So that's why I said it's 3, 5. But I don't see how you could decide whether it's a 1 or a 5. Remember, no order means that, there could be a duplicate here, but so does 3, 5, 1 imply there's no order. So I'm thinking triangle cannot be a 3. And then if it were a 5, I guess it could be 5, 3, 5, but not 5, 3, 1. Okay, so this is going to get a little bit tricky. Let's see. I guess let me go ahead and start off with 1. Okay, so triangle 1 means that we could have 1, 3, but not 3, 3, and not 3, 5. So 1, 3, 1 seems to be the only possibility with 1, 3. What about 1, 5? If it's 1, 5, then you're forced to have a 3, so it's got to be 1, 5, 3. Okay, 1, 5, 3, yeah, okay. And I think we said that 3 is not a possibility because, well, definitely not 3, 3, and 3, 5, 5, and 3, 5, 1 sort of imply that there is no order, so there's no way to distinguish. And then what about 5? So it wouldn't be, I guess it could be 5, 3, 5. What about 5, 5, 3? Oh, well, let's do 5, 3. Not 1, because that's a descending. Not 3, because you can't have more than 1, 3. So 5, 3, 5. And then what about 5, 5, 3? Okay. So in all these cases, what do we see about square? We have 2 cases where they're equal to 3, and we have another 2 cases where it's bigger than 3. And then what about criteria card C? Triangle is less here, it's less here, it's equal. Oh, okay, so here we know it can't be 5, 5 because of the equal. So we can eliminate that. And then here we have a case where triangle is greater. And then we've already kind of taken care of the number of odd digits, the sum, and I believe all these do describe a no order. Okay, so it does seem like we have to go one step further. And so the question is, out of these 3 potential solutions, which one's the best to test? It would seem that, let's see, it seems that this is the only one that has a square that's greater than 3. And I guess if it's not, then it'd be equal, and then we could always test which one's bigger or smaller, triangle or square. Okay, well I'm going to test 153, and if that's the case, yeah, I may actually have to do 2 tests. Wow, so this is going to be surprising if we have to go to 8 tests overall. But let's go ahead and test 153 as my new third proposal, 153. And so I'm going to test what square is. I'm going to test whether it's equal to 3 or greater than 3. So that's criteria card A. Okay, so it does not approve of it being greater than 3, so we know it's not greater or less than 3. So we can cross this out, and so we know that square is definitely 3. So let's go ahead and cross out the 5. Okay, and so it's between 131 and 353. Let me cross this potential solution. And I suppose we're going to have to test criteria card C, because the square is greater in one case and lesser in the other. So let's go ahead and test criteria card C. Okay, so it also disapproves, if you notice, a triangle should not be less than. So it's not 131, because in that case, triangle is less than. So that means it must be 535. So let's verify what we have. If we're proposing that our final solution is 535, yes, square is a 3. There is a single 3, yes. Oh yeah, I guess I should cross out, let's see, for test C, it shouldn't be less than. Triangle should be greater. Oops. So cross that out. So yeah, so in this case, triangle is larger than square. The first is larger than the middle. Yes, that's correct. Of course, there are all odds. We already sort of concluded that. Their sum is odd. And technically there's no order, right? It goes from 5 to 3, then back to 5. Okay, well, it seems like it meets all of the different criteria. So let's write it out. So 535. So let's go to turingmachine.info and verify. Oh, that's a little, wow, somehow I must have closed that window. So I don't quite remember. I do remember I had 8 tests. So let's go ahead and test 535. 535. Okay, so we did get it correct, but unfortunately, for some reason, that window got closed. I'm not sure what happened. So I will enter, 8 somewhat random tests just to kind of give it the validity. I think I remember maybe testing D and E. I think it was like the last ones, and we'll just say they're all wrong. And then we'll add another turn in, again, I don't quite remember what it could have been, but I do remember that we did have 2 tests, and we'll just say it's those, just to get an idea. So unfortunately, we did not beat the Turing machine. There may have been a miscalculation on my part. Maybe there could have been a deduction that I missed. So the Turing machine got the better of us today, but we'll fight another day tomorrow. But if you did enjoy this video, please give it a thumbs up. If you did notice where I could have gone wrong, please add something to the comments. Or if you have any suggestions, I definitely would love to hear what your thoughts are. And if you don't want to miss any future videos, make sure to subscribe to be notified. Until next time, have a good one.